Good day everyone. I will discuss to you my topic about design of experiments and multivariable testing. Design of experiments or DOE and multivariable testing or MVT are techniques used in experimental design to systematically and efficiently explore the effects of multiple variables on a process or system. Both methods aim to optimize and understand the relationships between input variables and output responses. So what is design of experiments? Design of experiments is a systematic approach to conducting experiments or tests in a way that allows the efficient exploration of the effects of multiple variables on a response. DOE involves planning, conducting, analyzing, and interpreting controlled tests to evaluate factors that may affect a particular outcome. Here are the key steps and concepts involved in DOE. First is define the objective. Clearly articulate the goal or objective of the experiment. Understand what you want to optimize, improve, or understand. So you have to set your objective in order for you to have a guide in achieving your goal. Next is identify factors and levels. Identify the independent variables or factors that may influence the outcome. Determine the different levels or values that each factor can take. It is important to identify the factors and levels of your experiment for you to be able to identify the problems of your experiment. Third is experimental design. Choose an appropriate experimental design. So there are several types including full factorial design, test all possible combinations of factors levels. Fractional factorial design, test only a fraction of the full set of combinations useful when there are a large number of factors. Taguchi design, a special type of fractional factorial design often used for robustness testing. Next is randomization. Randomize the order in which experiments are conducted to control for the effects of uncontrolled variables and reduce bias. So the basic benefits of randomization are to eliminate the selection bias, balances the groups with respect to many known and unknown confounding or prognostic variables. Next is replication. Conduct multiple runs of the same experimental conditions to ensure the reliability of results. Replication helps account for variability and provides a more accurate estimate of the effects. So in replication, it is one of the key ways of the scientist to build confidence in the scientific merit of results. Because when the result from one study is found to be consistent by another study, it is more likely to represent a reliable claim to new knowledge. Next is data collection. Conduct the experiments and collect data for each combination of factor levels. Ensure that the data collected is accurate and reliable. So in data collection, it is important in various domains because it provides valuable insights and supports decision making. Next is statistical analysis. Perform statistical analysis such as analysis of variance to determine the significance of each factor and their interactions. Identify which factors have a significant impact on the response of variable. So statistical analysis can provide valuable information needed to make decisions when solving a problem. Next is optimization. Identify the optimal settings for the factors that lead to the desired outcome. This can involve finding the combination of factor levels that maximizes or minimizes the response variable. So optimization is important because it helps to improve the performance of a system, process, or model, and can also help to reduce costs, increase efficiency, and improve the quality of the results. Next is verification. Validate the results by conducting additional experiments or tests. This helps ensure that the findings are robust and applicable beyond the specific conditions of the initial experiment. So in verification, it use of empirical data, observation, test, or experiment to confirm the truth or rational justification of a hypothesis. Next is documentation and reporting. Document the experimental design, procedures, and results. Prepare a comprehensive report that includes details of the experiment, statistical analysis, and conclusions. So in documentation and reportings, it helps you stay organized and on track by providing a clear understanding of the project requirements, progress, and any potential risk. The importance of design of experiment. The design of experiment is a crucial and powerful tool in various fields, and its importance stems from several key advantages and contributions to the scientific and industrial processes. So here are the benefits of DOE, or the design of experiment. First is the efficiency. DOE allows the exploration of multiple factors simultaneously, reducing the number of experiments needed compared to one factor at a time approaches. Next is cost effectiveness. By minimizing the number of experiments and focusing on key factors, resources are used more efficiently. Next is statistical rigor. The use of statistical methods provides a rigorous and objective analysis of the experimental results. And lastly, the optimization. DOE helps identify optimal conditions for a desired outcome. Next is multivariable testing. So what is multivariable testing? It is a method used in marketing, web development, product design, and other fields to simultaneously test and optimize multiple variables to determine their combined impact on a desired outcome. MVT is often applied in the context of A/B testing, where variations of multiple elements are tested concurrently to identify the most effective combination. So multivariable testing is a powerful tool for businesses and organizations seeking to optimize their digital presence, marketing strategies, and user experiences by systematically testing and refining various elements in a controlled and scientific manner. Here are the key aspects of multivariable testing. First is variable selection. Identify the variables or elements that you want to test. These variables could include different versions of headlines, images, colors, layouts, calls to action, or any other factors that may influence user behavior or outcomes. Next is variations. Create different variations for each selected variable. For example, if a testing web page, you might create different versions with variations in headlines, images, button styles, and etc. Next is randomization. Randomly assign each variation to different groups or segments of your audience to control for biases and external factors. So randomization helps ensure that the groups are comparable. Next is measurement of metrics. Define the key performance indicators or metrics that you want to measure. This could include conversion rates, click-through rates, engagement metrics, or other relevant indicators based on your specific goal. Next is statistical analysis. Analyze the results using statistical methods to determine the impact of each variable and the interactions between variables. Statistical significance is crucial to confidently identify the effectiveness of each variation. Next, we have iteration. Based on the results, refine and iterate on the variables to improve the desired outcome. So this iterative process helps in continuously optimizing and refining the tested elements. Next is control groups. Include control groups that do not receive any changes. So this helps to establish a baseline for comparison and ensures that any observed effects are attributable to the changes introduced in variations. Next is sample size considerations. Ensure that your sample size is sufficient to detect meaningful differences. Inadequate sample sizes may lead to unreliable results. Next is ethical considerations. Consider ethical implications, especially when conducting tests involving human subjects. Ensure that the testing process is transparent and participants are informed about the nature of the experiment. Lastly is the implementation. Implement the best performing combination of variables based on the results of the test. This may involve updating a website, refining a marketing campaign, or making adjustments to a product. So here are the benefits of MVT, or the multivariable testing. First is efficiency. MVT allows the testing of multiple variables simultaneously, saving time compared to testing each variable independently. Next is synergy analysis. MVT helps understand how different variables interact with each other, providing insights into combined effects. Next is data-driven decision-making. By relying on statistical analysis, MVT enables data-driven decisions and optimizations. Next is continuous improvement. The iterative nature of MVT allows for continuous improvement based on ongoing test results. So what is the importance of multivariable testing? Multivariable testing is a powerful tool that allows organizations to optimize their strategies, improve user experiences, and make data-driven decisions in a more efficient and effective manner. It plays a crucial role in staying competitive and adapting to the ever-changing landscape of user preferences and market dynamics.